These homeowners are in a state of shock and have experienced a traumatic event and a loss of a huge scale. So I think really we want them to understand we're there to help prevent this in the future. We really want to gain an understanding of why this is happening and why it's happening at this scale and what are the things we can do to prevent it.
I find these post-event investigations the biggest lab that nature offers to us. So we can go outside, we can look at these destruction while it makes us think about the rebuilding process. At the same time, it gives me the information how to design these experiments to replicate what happens in the field, and I think that has a lot of value.
The wildfire deployments give us the opportunity to take the research that we're conducting here at the IBHS Research Center into the field and validate what we're seeing in the lab environment is what we're also seeing in the field.
Once we built the research center and actually had active wildfire research, we really started a more field, boots on the ground kind of field deployments where we actually went to different wildfires post-event and examined the damage to different building structures. Most notably, really kind of the start of our largest endeavor in that is the campfire in Paradise. We also deployed for the Marshall Fire in Colorado, Lahaina in November of 2023, and then most recently we had a post-event investigation during the Eaton and Palisades fire this past January.
My wife and I were getting ready to go up into the mountains to play in the snow that afternoon, and she had smelled some smoke outside, and right after she mentioned that she smelled smoke, I got an alert saying that there was a grass fire in Boulder County. And just being Boulder County, I had assumed that it was up in the foothills.
The embers from here to here. It's actually very informative to come to the field and look at the real examples in the world. We saw examples from very small closet-sized sheds all the way to large sheds, which is phase 1 of SSE that we're working on right now. And also structure-to-structure fire spread. We saw that like 10 feet, 12 feet, we saw a lot of examples of fire spread between houses like that. And I'm very optimistic from this project and the outcome of this that we can have a real-world impact to change the risk and understand the risk better.
I saw the fire hit original town Superior, and all of those old houses start to just go up in flames. And at that point in time, I called my wife and I said, pack some bags, get the cats into the cat crates. We probably need to evacuate.
So one of the questions that we had as we approached this fire investigation was to look at the elements of the wildfire prepared home. These kind of fundamentals about the roof, the vents, and then that 5 impeccable feet. And ask the question, does that still extend in this kind of ignition and this kind of conflagration? The answer is yes.
Which features correlate to those that survived, right? Oftentimes when structures are destroyed, we can't make that correlation, right? Because we don't know what was there beforehand. But by looking at structures that were survived or partially damaged, we can look at the different aspects or attributes of the building, the surrounding environment, and connective fuels, and ultimately understand how the fire spread through a suburban neighborhood, and ultimately to understand different mitigations that matter, and correlate that back to the research that we've done here at the Research Center.
Todd's Ohana isn't quite going yet. Todd's house is still okay. Our house is okay. The Mellow's gone, Uncle Jay's gone, corner house gone.
We bought the house out here 2 years ago. It was the 9th would have been the 2-year anniversary, the day after the fire. We wanted to retire out here. I'm a firefighter in California for O'Reilly Hills Fire Department, captain there. Been in the fire service since 1999 in California.
Sorry, Uncle. There she goes.
I'm next. Gotta go. And we decided we wanted to move out here in retirement, but with COVID happening, we said, why are we going to wait? Let's just go do it now.
Mountain is Malta. We call it Malta wine, but actually when it was initially burning, it was going towards the ocean. So the smoke, you can see it from here in town, it was just going straight down. And then I guess it changed direction and it started coming north. So the town burned and then the home started burning from town to this direction.
How's this going everywhere, all the way down to the ocean?
Being on the ground in kind of a conflagration environment as well, where there is total destruction, there aren't a lot of things that kind of tie you back to what you're looking at, was a really, from a science perspective, kind of an interesting learning experience, but from a human perspective, it was a really kind of emotional and challenging environment.
So really the field deployments and the research we do, or the physical research we do here at the research, are really complementary to each other, right? It's a two-way street. It's not unidirectional in terms of the information. So from our research, we have an understanding of how fire can spread between vegetation and structures, from a structure to structure, and we look for aspects of that, of how that could potentially play out in the field.
The other is try to understand how is the fire enter into the community to develop guidelines that can reduce the likelihood of conflagration. In the case of the Lahaina deployment, we saw that the fire entered basically from a grass fire. So the fires spread from grass and they start touching combustible materials within the parcel, and then that make homes ignite, and those homes generate a lot of embers, and embers fly away, ignite other homes, and then the cascade effect happens.
We talked about it, went from the grass to the car. The car made longer flame lengths. Those flame lengths got across and caught the other vegetation on fire, which was, only a couple feet away from the back structures, and started those on fire.
And sometimes we see confirmations of what we've seen at the research center and at the lab, and other times we see new aspects to this that we hadn't previously considered. So one specific example of that was during Lahaina. We looked at really vehicles being a connective fuel. So we'd studied a lot about vegetative materials or building structural materials as being either connective fuels or allowing fires to spread through a suburban environment. But really during Lahaina, the vehicles really came out or pronounced as a potential for fire spread through these communities. So that was something new that we brought back to the research center as something that we should maybe investigate in a little bit more detail.
So it was my first deployment, and from the scientific perspective, it's just great to be able to collect that amount of data that could be meaningful, but for the human perspective, it's hard. Just stand there and look around, and it's just, everything is destroyed.
The work that we did as a team on the Lahaina deployment really kind of set a lot of groundwork for understanding these conflagrations. The situation in Lahaina resulted in a lot of really unmitigated fire spread within a community, and that helped us understand, to understand those three pillars of conflagration: structure separation, connective fuels, and building materials.
It could happen to anybody. You never think it would happen in Maui. When I left Tahoe, I'm going, well, at least finally I'm getting out of wildfires. And here we are in Maui, and we're in a huge wildfire. So never think it couldn't happen to you, because it could happen anywhere.
They had good defensible space. They just dealt with the radiant heat.
We are in LA metro area to study the Eaton fire and the Palisade fire. We spent about 4 days in Pasadena and Altadena to look at the destruction that this fire caused in that area. We surveyed about 100 homes when we looked at structure separation, building to building fire spread, connective fuel within structures, and of course building material. Today was the first day that we started our investigation for the Palisade fire.
What happened is, with this pergola, is embers came in and lodged in between some of these purlins and the main beam that's attached to the house, and they had some sort of corrugated maybe vinyl material over top of it, and that was completely consumed. And so once the fire got established in this wood structure from the embers, then I was able to travel laterally, get up underneath the eave line here, and then travel across and burn its way through this like freeze blocking that they have up here, and then travel up underneath the other solid wood structure surface area. If we see something new, maybe we haven't researched before, and we're seeing it in the field, we can bring it back to the research center and conduct further research on that. And that's really what happened with the structure-to-structure fire spread experiments that we're conducting here in coordination with CAL FIRE. Is structure-to-structure fire spread is a significant contributing factor to urban conflagration. And we saw that during our post-fire analysis, and now we have the opportunity here at the Research Center to really dig into that and look at that relationship of the spacing between structures and the materials that they're made out of.
This home is unfortunately a case study in the vulnerability of that 5 feet closest to your home. Crew, the firefighters got to this home and was able to back this down. But you see the open eaves that brought the fire up and throughout the roof pieces here. Clearly this tree was fully engulfed.
So we have long looked at other combustible objects that we haven't really conducted any research, or there's very limited research that's out there in general, and hot tubs is one of those. We saw 2 clear examples where hot tubs ignited, leading to significant damage to structures. And those hot tubs were both located within 10 feet of the structure. And so we were able to really validate what we thought about hot tubs, their combustibility, and what we had built into the wildfire prepared home standard for hot tubs of being a 10-foot separation distance between the exterior wall and the side of the hot tub. So that really was able to validate that distance that we had determined was the right distance.
Is there a pathway the fire could take on the different sides of the house to get to the house, or is it disrupted? We have Zone 0 in place that disrupts that pathway.
We're really looking to make the most of our science and translate it into action. So these deployments really help us do that. We want to look at the specific things that we observe in deployments and turn that into experiments that grow our understanding that will then go and make a difference.
For the foreseeable future, I think post-event deployments following large wildfires or suburban conflagrations will be part of IBHS's research program. Really at the moment now, there's still a lot of unanswered questions, still a lot to learn from these fires. So for the foreseeable future, I think we will continue to go after these tragic events, learn as much as we can from them to hopefully take that information and really try and make these less frequent, so that, in the ideal scenario, we don't have to do these post-event because there aren't these significant conflagration events to do these deployments on.